video, we continue from the last parts to do this rotationally extruding exercise, and we will use finish the first part first, then going to create this kind of the new wheel. So let's go to our chapter 8. So we finished the last video at this model, and we are finished this part first on this exercise, because we did this model. If you read the paragraph, is we made our circle and made rotational the extruding, and then we insert our 3D object. It's a cylinder. But when you examine this 3D finished object, is our symmetric object. So whenever you identify our object like this type, it will give us possibilities. We can create our purely 2D the object first or shape first, and just use one step rotationally extruding to get this finished one. So let's did this together. So what we will do is we will introduce our new 3D command is square, except besides this circle. So let's save another one. Rounded circle. So it's the method 2. So we don't use a cylinder. So let's remove that. But instead of we have only one the translate this circle, we will do another translate. So that is this one. So let's see. So made our square. Let's copy this here. So for square is you have this length and the width. Then you can make this here. And then let's first comment this two. Then you can see here. Let's also comment this. Let's see what we have. So we have one circle, one square, and what we will do is this square is not in the center. So we also need to make some the translate, make that into the below a little bit. This direction is a minus y. So translate. X is 0 and y is minus wheel weights divided by 2. Then we have this. Then we can see this square is put in here. You can also have a square. I think we have this center true. So, but we don't need that, because if you put center true, it's in this center. And then we will have this. So if you want to uncommand this, Control Shift D. So this one, let's see. So we have our circle move to this positive X. Then what we will do is now we can do this rotate, and we just rotate along this axle. So we have we need to have these curly braces, and Control Shift D. Let's see what we get first. So we get this one directly, because when we rotate, is this square is also rotate. So we can see if we comment this one, then what will you get? square, first they rotate the first 90 degree, then they make the rotate with 360 degrees. So that actually make our cylinder. So what we have is now we have this one. Then if we have our final rotate coming, so let's see, we get the same result. So let's see what this means. So same, that is what we are doing now. Let's give them our module. So because we will reuse this, so we called this module rounded simple wheel. So what such kind of the perimeter we will have, and first we get our curly braces. So we have this one, rotate, that is the first tab. Let's see, so that gave this first tab, and this will be the second tab. Yeah, that is so. And then what's the perimeter? So we have a 2 perimeter. Wheel radius equal to 12, and wheel weight equal to 4. Or we also have this tire diameter equal to 6. And then we can start into code. So with this rounded simple wheel, we made that comment, then that's disappear, then we start into code is coming. So that is what we get on this the new wheel, and we save that. And what we will start to use this to do this the challenge is we will build this interesting new type of wheel. So first is what we will do is we did our this rounded the wheel with this adding a hole. So let's go here. So it's already saved. Now we have this part 2. One rounded wheel. So what we will have is because we don't need to define this 6 anymore, and then we have this module, and we also make our the axle diameter. So that is the middle hole. And then this hole means we have this wheel. Then we will do the this hole. The is a difference than is from the middle. Then we have this rotate. So that is our difference coming. So difference. Wheel part is this one, and what we will have is the axle hole part that will be removed. Rotate. So we have this 9000. Then what we will have is just a cylinder. H equal to wheel weights. So this +1 means this inner hole should be a little longer than the external one, so that you can ensure is you can make this removed completely. Diameter divided by 2, center equal to true. So what we will get is, let's see, we have our arrow, because we now missing one curly braces. Yeah, that's perfect. Let's see what's the perimeters looks like. It's 12, 4, 6, 3. But our this shape is not exactly the same like this. So 93 degrees wheel radial divide this. This is same. This is same. This is same wheel anxious axial wheel base. So looks like it's this wheel base is not so big. So wheel base divided by 2. This circle D equal to this one. So is this so big? See, looks like it's similar like this kind of the part, but here is the tire diameter is 6 and 3. So this code is different to what I can test it here. I think it's this on the tutorial possible is missing one divided, but the code is the tire diameter is 6, so that is, let's make that as 3. So it looks like it's this perimeter possible is not correct, but let's use this 3 so that it looks similar. Save. And then this rounded, you can see here, where now is changing this perimeter. So now it's 20. And then it should have a comma. Bigger. Oh, that is correct. From here is we are adjusting the dimension. So tire is diameter is 4. Axial, this hole is 5. No, I think it's coming to this shape. So let's save. This is our default dimension. So it's this one. Now we will have ways we actually this is not like a wheel. We need to build this wheel. So well, what are the ways we can remove this one? So we have two approach. So let's save on this. So we will build another two model. So let me save this as second robot ring from profile difference, using the difference to remove the external this donut circle. So we will have this rounded simple. So that is the part we have those. And we will have this cylinder +1. So that is our, let's see, so difference, rotate, difference. So they put this rotate outside. So here is rotate is inside the difference, making that is the 3D. But here is a rotate outside, so we have to rotate this and make this as a 3D, and we make this as a cylinder. So let's see what's the difference for this one. So let's move this, and the result rim is rotate extruding from the difference. Oh, difference is this cylinder is a difference to here. So rounded. So let's say rounded simple wheel. Wheel is 12. This is 4. This is 6. That is 7. And we move this rotate outside. Rotate Then after that is the difference. And what we are doing is resulting ring. So let's say here we directly have this rotate angle 360, and after that is we have the difference with this, and the difference is after this. So first we have our translate. Let's make this inside. Translate wheel. So this should be the cylinder. So it's this one. The square first. I tried to change from the existing code, but if you want to just starting from scratch, it's also fine. So I want to see the any difference. So here you can see we have first this rounded square, then divided by this rounded rotate extruding circle. That is getting the circle is that's the donut tire. The donut circle is divided. So this is the tire profile. So that is the thing, and we have our axial hole. So this hole is just our cylinder. So since we have this rotate outside, so it's no need to have. So that is this is the first one. This is the second one. This come to this one, and this come to this one. This come to this one. But to this dimension, actually, I think is they're using this updated dimension. So that should be the 20. This should be 6 and 4, 5. That will be more reasonable. Let's see. So that we got on this first approach is we do the rotate, then we extrude, we difference this donut ring, and then we make this hole. So that is one way when you produce this shape. So let's save that. Let's see the second approach. The second approach is we have the cylinder, and the difference by this, and then we have this the axial. So these two resulting. So cylinder cylindrical ring. So we don't have. We are putting this cylinder first. Is this one, and then difference by the tire. So this rotate is the difference, and then we make this hole. So let's see what's the that difference. So we have this cylinder reel. We are not using the square. We just make our the cylinder directly. So we have this tire, but we make this rotate outside. So tire, then we have this translate. So that is our first translate and the circle tire, and this will be our shape to be different. So cylindrical ring. Then we will make a cylinder. This cylinder will have this H equal to wheel weights, R equal to wheel radius minus tire diameter divided by 2. Ensure is center is true. So we have that, but we need to make some difference. So we have this difference, and we have this. I think that is true, and this difference is applying to this two. So let's see. So this two. So that's the difference, and this outside difference we will rotate that to this 90 degree. Difference is here, and then we will have another the axial, this one, and this has no need. So we don't have this hole to be differenced. So we also need the difference this, and also put hole inside. So we should have also make the hole. So that is coming from here. So you can see that is the two approach. When you read here is why we can do this by two different ways. Fully depends on is how you think about this structure. So are you going to build the circle, then minus the circle, or you want to build this the cylinder and do this? That's also depending on which type of your 3D printing is actually based on. So some 3D printing is is through the adding the things. Some is through the removing. So that's depending on the type. Which is will be the certain matter if a different approach will use a different type of the material or different amount of the material for printing that or for making that in real the shape. So you can try to consider this two way. I gave you this both two models in the GitHub. Then you can make all of them is read. So what I will do is let me see the update chapter 8 in the GitHub. So I push to here, and you can always come to this the repository. I keep updating this within this tutorial. Now we are already in chapter 8. All of the model I made is putting here. And if you have one model, you can render that. Just wait a second. It's parsing this design. And we can make that available into C. So export that to our STL file. And then when I make this pushing to here, then some file is I gave you the STL model. So like this one. So this is the model. If you click model in the GitHub, you can get this 3D view based on the GitHub's the built-in the capability. So that is very interesting. So you can have your model directly see what that looks like in the real way. So that is the printing the manner. So you have this wireframe. You can see the inside or circle surface angle. So there's the different angle. They have different colors. Then they have the solid color. So that is the thing is you can enjoy from the GitHub, and also we will continue the next video for this linearly extruding. So that's the second method using the 2D to generate 3D. So see you in that video.